Today we supposed to start the circular motion in a vertical plane. That's the heading, right? Write down people the heading as vertical circular motion. Vertical circular motion. Vertical circular motion. Fine. Okay. Now, to illustrate this, I'll take people one example like this. Suppose we have a fixed point O, right? Fixed point is O here. Right. O is a fixed point. This way, O is a fixed point. One end of a light inextensible string is joined to the point O. The other end is joined a particle of mass m. The length of the string is suppose simple A. Okay. The string is light inextensible string. Length is A. One end of the string is joined to a fixed point O. The other end is joined a mass simple M. Now, while this mass is resting in a vertical line like this particle is given a horizontal velocity u. Horizontal velocity u is given. Right. Then what happens is the particle begins to move in a vertical circle. In a vertical plane, it moves on a circle like this. Now, I'm going to draw this way horizontal line. I draw this vertical line. I'll take this lowest position as A. This horizontal position B. This highest position C. Right. When the particle is given this way, the velocity u, initial velocity u, suppose the time is 0. Right. Now suppose during a time interval simple t, particle reaches to a position here during a time interval t. Okay. That occasion, suppose the velocity of the particle along the tangent V, tension in the string is T. Weight is mg. So this angle will be theta. Right? Right. Now, this is the diagram. Now, people, depending on the size of the initial velocity u, the particle can get one of the following results. First is this. Number one. Right? Depending on the size of the initial velocity u, one of the following things can happen. First thing is, this particle can oscillate above the line OA to both sides. The particle can oscillate. Before reaching this point B, when theta is acute, the particle can oscillate this way. Particle can oscillate above the line OA so that this theta is acute angle. That is first possibility. Second possibility, people, the particle may leave the circular motion and that can begin the projectile motion. That means particle rises this way and passes the point B. And before coming to the point C, the particle can leave this circular motion and that can move under gravity as a projectile motion. That is second possibility. Third possibility is, people, particle can move, reaching to the highest point C. Particle can pass the highest point C, and then the rest part, this semicircle, particle move on the rest semicircle very easily. That means particle moves in complete circles very easily. That is the third possibility. Fourth possibility is particle can just move in a circle. Just move in a circle mean, people, at the highest point, the particle actually thinks to stop the motion, but with huge difficulty, it passes the point C and again it moves in the rest part of the circle. That is the fourth possibility. That is called as particle just passes the point C and complete the circle just. There are the four possibilities, right? People, the other thing is, once the particle moves this way, particle has velocity V and string has tension T. This velocity V and the tension T both vary, right? When velocity is 0, particle can't move on the circle from that position. That means when the velocity becomes 0, no longer particle moves. That stop instantly there and come back. Now, for example, if we give the initial u value a less value, particle moves on the circle like this. Suppose somewhere here the velocity of the particle becomes 0. No longer particle rises on the circle this way. Velocity 0, then it comes back. Right? So therefore, when velocity is 0, no longer particle moves on the circle to the same direction, it comes back. When tension T becomes 0, soon after tension T becomes 0, next occasion tension going to be negative. Tension 0 mean, people, the string is in natural length. Tension 0. Tension negative mean, people, the string gets slack like this. This is tension negative. If tension is negative, people, that tension begins to come to negative. First, the tension comes to 0. Thereafter, it comes to negative. At the moment tension becomes 0, next occasion the tension going to be negative. At the instant tension becomes 0, people, the particle no longer supposed to move on the circle. Why? Next occasion, a string becomes slack. It becomes like this. Then the particle does not move on the circle, because if the particle moves on the circle, the string should have the its natural length simple a, then only the particle moves on the circle with center O and radius a. So therefore, people, this T tension and V velocity of the particle will vary as the particle moves. People, now we can really prove mathematically in between A and B, out of these two things, tension T and velocity V, if something becomes zero, we can mathematically prove the velocity becomes zero, right? Velocity becomes zero before the tension becomes zero. Velocity V and tension T both vary. If out of these two things, velocity and tension T becomes zero, the one which comes to zero first is velocity, not the tension. If velocity is zero, while having the tension, what can you say? Particle stops there, but still it thinks to move on the circle because tension has a value. That means spring is natural length. That means particle should move a distance simple a from O. That means on a circle with radius a. Okay. So therefore, mathematically we can prove in between A and B, if T and V, when we consider, if something becomes zero, that is velocity, not the tension. And due to that, what happens, right? The particle moves on an arc above the line OA, so that theta is acute, right? Well, secondly, between B and C, out of these two things, tension T and velocity V, the tension only can be zero first in between B and C. That also we can prove mathematically. In between B and C, right, there is tension T and velocity V, right? The variable which can come to zero first is tension T. That also, that depends on initial velocity u. There's a particular range for this u, initial to u. If we project this particle with that velocity, right, in between B and C, right, out of these two things, tension T and velocity V, tension T is the one which can come to zero first. Tension zero means next occasion tension becomes negative. That means no longer particle is moving. Particle doesn't stop. Why? It has velocity now, but tension zero, next moment negative. That means spring going slack. Therefore, particle is not moving on the circle. That begin to move in between B and C, at the point in between B and C, that begins to move as a projectile like this under gravity. Understood? So therefore, people, if this particle leaves the circle, that can happen at a point between B and C. Understand? Right. So that happens due to what? Due to tension becomes zero while having velocity. Right? Okay. That tension becomes zero. That means particle, if the particle leaves the circle, it leaves at a point B and C. We can prove that also mathematically. That result also occurring due to the initial value of u. The initial value u has particular range to project the particle. If we use a value in that interval for this u and v project, the particle leaves the circle at a point between B and C and begins to move in as a projectile in the gravity. Right. People, the next thing, the particle can move in complete circle very easily. That means if we give initially a huge value for this u, people, without any trouble, particle moves this way and coming to the highest point, and then rest part of the circle it moves smoothly without any trouble. So this the condition required people, you might think, in order to complete the motion of this circle by the particle passing through the highest point, right? Completion of the whole journey. The condition required people, you might think at the highest point, the particle should have a velocity. Well, that is not the condition required. At the highest point, velocity of the particle becomes zero is not the condition required. The condition required is at the highest point, point C, at the highest point, the tension in the string. People, the tension is positive. If the tension is positive at the highest point C, that is the condition required for this particle to complete the whole circle very easily. Right? That is the condition required, not the velocity positive. Right? At the highest point, velocity positive is not sufficient for this particle to move in complete circle. That means people, suppose particle came to the projectile motion somewhere between B and C. Then somewhere here it is starting the projectile motion, and it moves like this, but not moving on the circle. But when the particle passes this vertical line, that is vertically below C, that location the particle has velocity, but the particle is not moving on the circle. So therefore, the condition required for this particle to move in complete circles is, people, at the highest point, the tension in the string should be positive. That's the condition required for this particle to move in complete circles very easily. Another condition, another result we said, people, what is that result? That result is the condition required for this particle to just move on the circle. The condition required, people, at the highest point C, the tension T becomes zero. At the highest point C, if the tension T equals zero, particle, people, comes to the point C and is about to fall down and never fall, people, it moves. And think, people, if this particle passes the point C this way on the circle, then definitely nothing will be happening to the particle. Particle will be moving on this circle very easily, right? If the particle, okay, if something happens to this particle, that thing happens during the motion from A to C. If the particle passes the point C, people, the particle will be moving on the circle, rest part also, this way. Understood, right? So therefore, people, these are the things that we have to first understand here. The other thing is, people, here, you can see, while this particle is moving on this circle, right, this string is the radius of the circle on which the particle moves. And this velocity of the particle is along the tangent drawn to the circle. The angle between string and this velocity is 90. In other words, the tension T in the string is perpendicular to the direction of motion of the particle. Direction of motion of the particle. Understood? You know, people, when we consider, we have learned about the work. Definition of the work, you know. What is, people, work? Work done by a force. Work done by a force is defined to be force multiplied by displacement. Here, people, force multiplied by displacement mean really this force should be in the direction of displacement. In the direction of displacement. Now, for example, suppose like this, we have a body, right? And we have a force like this. This angle is theta. Now, this body moves, right? A displacement simple d because of the action of the force F. Then in this case, work done by this force F is given by the displacement occurred to this direction. Then we have to find the component of the force along that direction, which is F cos theta. F cos theta into d. Right? This is the work done by the force F. Now, here this T is an external force. This tension T is perpendicular to this direction of motion of the particle. By this T, no component along the direction of V. Therefore, this T does not do any work on this particle. Right? Now you know the conservation of mechanical energy. We learned that where? We learned that in, I think we learned that where? In impact of elastic body lesson we learned. Another occasion we learned that relative acceleration, no? Yes, we learned that. Yeah. What is that? Conservation of mechanical energy, people. Conservation of mechanical energy says when a particle moves in a conservative field of force, right? Conservative field of force means, people, the good example for that is the gravitational field. So you know, when we, of course, arrange to fall this way a particle of mass m, right, to the ground, at the instant of releasing that, suppose the height is h, then if we consider this potential energy 0 level as the surface, that means the ground, when the particle is released from this height h, we say the particle has potential energy mgh. That is the initial energy. Once the particle moves a little distance down, then it will have a velocity v. And now the height decreased. Now, in this case, once the particle passes this level, it has both potential energy and kinetic energy. What is the kinetic energy? Due to the motion, the energy particle possesses is called as the kinetic energy. Kinetic energy equation is half mv squared. So therefore, here we can find the potential energy. It is mg capital H. Kinetic energy half mv squared. The sum of these two we define as the what, people? Mechanical energy. Mechanical energy of the particle. Then this conservation of mechanical energy says this initial energy, potential energy, is equal to this energy, right? So then this is true whenever this particle falls in a conservative field of force. This example is the gravitational field. And furthermore, it says the particle may move, people, in a different path like this. Irrespective of the path, whichever the path, this total potential energy and kinetic energy total is called as mechanical energy. This mechanical energy is always fixed. Always fixed. That is what the conservation of mechanical energy states. People, in this case, while the particle is moving this way under gravity, only external force acts on that, is its weight, people. Its weight. Weight, remember, people, weight is an external force. How do we define the weight? Weight is a force which acts on a particle. How? Weight is people. When we keep in the space a particle like this, suppose this is our Earth, right? This particle is attracted towards the center of the Earth by a force. This particle is attracted towards the center of the Earth by a force. That force only, people, we define as the weight. Therefore, weight is external force acting on the particle. So while this particle is moving under gravity like this, the only force acting on the particle is what? This mg, its weight, right? No external force. But here, people, the particle is, this particle also, this time, the particle is moving in the gravity that moves on a circle. And not only the weight mg, but tension also acts on the particle. That tension is an external force. But even though this tension T is an external force, as I told you, this tension T is perpendicular to the direction of motion of the particle. The particle will have a displacement along the tangent, but tension T is perpendicular to that. Then this T won't have any component along the direction of the tangent. Therefore, people, while the particle is moving on the circle, the external force tension T does not do any work. That means the tension T does not give any energy. Work means what, people? Energy. Right? The tension T does not do any work on the particle. The tension T does not give any energy to the particle because the tension T is perpendicular to the direction of motion of the particle. Therefore, the particle will have displacement along the tangent of the circle towards that direction, no component by the tension. Therefore, tension T does not do any work. Then, even though the particle is moving on this circle, that is similar to moving under gravity like a particle moves like this. We said, whichever the path, the total mechanical energy is constant. The same situation this particle has, because it also moving under gravity, but it moves in a circle. Moves in a circle under gravity. Though the tension T acts as an external force in addition to the weight, the tension T does not do any work. So therefore, people, for this case also, this conservation of mechanical energy must be true. That means, people, if we select here this level as the potential energy zero level, people, at this moment, the total mechanical energy of the particle, and at this moment, the total mechanical energy of the particle should be equal. Understand? So therefore, in this case, people, to obtain one equation, right, we use the mechanical energy. At the initial instant, the total mechanical energy, and at time t equals t, the total mechanical energy should be equal to each other. Thereby, we can obtain one equation. The other equation, people, we obtain how? Apply F equals me towards the center of the circle. That way, basically, we take two equations, right? By using that two equations, people, we can find that velocity v and tension T. Okay, so this is the first thing you must understand, right? Okay, so now, people, shall we take down a brief note? Right. Right. Now write down like this. Write down like this. Consider a particle. Consider a particle of mass m. Consider a particle of mass simple m joined to an end of a light inextensible string of length simple a whose other end is joined to a whose other end is joined to a fixed point O. Right? Now write down when the particle rests at the lowest position it is given initial horizontal velocity simple u. Suppose after time t, particle turns through an angle theta with downward vertical. Right. We will draw this diagram. Draw diagram. Right. Mark this A, B, C, O, this angle theta, tension T, velocity V, time T equals T, mg, and T equals 0, mass M, the length A, and potential energy 0 level. All we have to mark. Huh? Right. Now, we'll write people. We'll write like this. Write down. While the particle moves on the circle, the tension T in the spring, the tension T in the spring the tension T, capital T in the spring is perpendicular to the direction of motion of the particle. To the direction of motion of the particle. Therefore, tension capital T in the spring, tension capital T in the spring does not do any work, on the particle. Therefore, the total mechanical energy of the particle, is always constant, Therefore, the total mechanical energy at T equals 0, and at T equals T, here and here, the total mechanical energy at T equals 0 and T equals T should be equal, right? Then you can write mechanical energy at T equals 0 equals what? Kinetic energy plus potential energy. The kinetic energy. This level is below the level of potential energy 0. When something is below the level of potential energy 0, we define the potential energy that particle possesses is negative. Okay. Above the level of P is 0, the potential energy considered as positive. Then it is minus mgA, because the height is A. mgh is the potential energy, no? Right. And the other one, people, mechanical energy at T equals T. It is half mv square is the kinetic energy. The vertical height to this level, that is this height, no? That height means when I consider this three people height, if this is theta, this is also theta. This length is A, no? This is theta, then A cos theta. And this height is A, this is theta, therefore this is theta, A cos theta. Then we get minus mgA cos theta. Okay? These two must be equal. Therefore, we can write half mv squared minus mgA cos theta is equal to half mv squared minus mgA. This m you can cancel. Then multiplying by 2 and taking this term to right hand side, you can subject this v squared. Then we get, once you take this right hand side, 2GA cos theta becomes, because we multiply this by 2, no? This 2 will cancel off. Q squared then 2GA. Then we can write V squared is equal to Q squared plus, right? I'll take this minus sign, minus 2GA out. 1 minus cos theta. This is the velocity, and by this, taking the root, we can find the velocity v. U squared minus 2GA times 1 minus cos theta. Right. Now, we apply, secondly, applying f equals ma towards the center at t equals t. At t equals t, right? Towards the center, we apply f equals ma. What is the force acting on the particle this direction? T. When I produce this way, this angle is theta, therefore this also theta. Then mg cos theta. Then centripetal force going to be T minus mg cos theta. T minus mg cos theta is the centripetal force. Is equal to m is the mass, simple m. Acceleration in the direction of the center, centripetal acceleration. It is v squared divided by a, right? V squared divided by a. Then you can substitute for this v by this answer. V squared is this. We can put that here. We can take this right hand side. Okay. Then we get T equals, bring this mg cos theta to right hand side. Mg cos theta plus m upon a. V squared means this. U squared minus 2GA times 1 minus cos theta. Now, people, we can simplify this little bit. We can take m upon a out. Here we don't have a, divided by a, multiply by a, then we get GA cos theta here. And here, when I take m upon a out, here we have u squared minus 2GA 1 minus cos theta. Then we get here minus 2GA minus cos theta is plus 2GA cos theta, and this GA cos theta is 3GA cos theta. Plus u squared minus 2GA. Right? So then this is the tension T. I'll take this 2GA out. Also take GA out with minus sign, 2 minus 3 cos theta coming. Right. This is the tension T. This is the tension T. Okay. Right. Now you can very clearly understand the velocity v here depends on initial velocity u and theta. If this initial velocity is u, it's a fixed value. As theta changes, this part will change. Then this inside the root sign, the expression will change. The square root after taking, then finally this b will be changing with the theta. Okay, and this tension T also function of theta. As theta varies, this term will vary, then this within bracket the expression will vary, then T will vary. That's why I told you as the particle mode, the tension T and the velocity B both vary. Right. Now people will write that possibilities in the subsequent motion this particle might have. Yeah. Write down people like this. Write down. Right, first obtain these results, the velocity V and the tension T. Write down. Soon after projecting, the particle at t equals 0, while the particle moving on the circle, it can undergo one of the following motions. One of the following motions. First one, write down, people. Number 1. Number 1, write down. Particle can oscillate on either sides of the line OA, with theta acute angle. This happens with theta acute angle on either sides of the line OA with theta acute angle. This happens the velocity V becomes 0 having a value for tension T. Right. Second possibility, write down number 2. Number 2, the particle may give up the circle, may give up the circle, the particle may give up the circle and begins to move begins to move as a projectile motion under gravity. Right? Write down, people. Do the same thing, write down. If this happens, it can occur at a point, between capital B and capital C, between capital B and capital C on the circle. This happens due to, on the circle, this happens due to tension T becomes 0 while having a value for velocity B. A value for velocity B. A value for velocity B. Right? Okay, here third one. Third one, write down. Third one. Particle can move. Particle can move on the complete circle very easily. On the complete circle very easily. On the complete circle very easily. The condition required for this is, the condition required for this is then the tension T, the tension capital T becomes positive at the highest point capital C. At the highest point capital C. At the highest point capital C. People within bracket write down not velocity v becomes positive, not the velocity v becomes positive at the highest point c. At the highest point c. Remember that condition, huh? Even fourth possibility, fourth one. Fourth one, right on. Particle can just move in complete circles. Particle can just move in complete circles. Right. Right on. The condition required for this is the tension T. The condition required for this is the tension capital T becomes 0 at the highest point C. At the highest point C. At this, all people, the theories under this you should know. Right. Now we'll come to one question. We'll take the first question as question number 11 in the tutorial, page number 5. Right? Page number 5. I think I put that PDF, no? Yeah. Right. Until you receive this tutorial through post, please follow this PDF copy. Right? Right. Right. Question number 11, take people. Question number 11 says, a particle of mass m is attached to one end of a light inextensible string of length L. Instead of this A, it is L. And the other end of the string is attached to a fixed point O. When the particle is at its lowest point, it is given a horizontal velocity u, this way. When the particle is, at time t equals t, particle acquires a velocity v, and the string makes an angle theta with the downward vertical by taking the level of O as potential energy 0 level obtained. This answer asking to obtain people. Once you take this side and v square to this side, you get that answer. And tension T in the string. This answer also asking to take. T equals m upon L should come, no? 3gl cos theta u square minus 2gl. These two answers we have to first take, right? Just draw the people diagram. Draw the diagram, and by applying the same way, the F equals ma and conservation of mechanical energy, and you can take these two answers, right? I'm not going to do that one. You must first do that. Take time and do that. Okay, the same thing you have to do, right? Alright. You can take this to this side, v squared this side, then u squared minus v squared. will be equal to 2ga times 1 minus cos theta. The answer you can take 2ga. The other one is equals m upon L gl cos theta plus u squared minus 2gl 1 minus cos theta. Then people here, when you simplify this, 2gl, we get 3gl, no? Yeah. 3g u squared minus 2gl, no? This is these two answers, I think, you can very easily take m upon L 3gl cos theta plus u squared minus 2gl. This way you take. That two answers, I think you can take very easily. Right, take the two answers. Okay. Apply conservation of mechanical energy. Taking this level, horizontal level through O as the potential energy zero level. Apply conservation of mechanical energy. And apply Fico-Semmer towards the inter. This way you can take these two answers, no? Now, some questions are asking like this. Show that if u squared less than 5gl greater than 2gl, the particle leaves the circular motion and in the subsequent motion it moves under gravity. If our initial velocity u is such that its perfect square is less than 5gl but greater than 2gl, now we ask to the particle leaves the circle and moves as a projectile motion under gravity. That's what we need to prove. Well, you know, if this particle leaves the surface in sense circle, leaves the circle, that can happen, we said, in between B and C. At a point on the circle between B and C, the particle leaves the circle. The condition required for that is what, people? Having a value for velocity, tension becomes zero. Tension becomes zero is the reason why the particle leaves the circle. Therefore, we start for the particle to leave the circle, the tension should be zero. Then we equate this tension T to zero. Thereafter, we subject this theta, cos theta. But we know if the particle leaves the circle, that happens above the level of V before the level of C, in between B and C. That occasion, this theta above the level of B means theta more than 90. Before C means less than 180. That condition we use there right now. Then you can try it like this. When the particle leaves the circle, this happens the tension T equals 0. Tension T equals 0. This is the reason why it happens. Tension T equals 0. Okay. Now we equate this tension T to 0. Then what do you get? M upon L, CGL of theta plus U squared minus 2GL is equal to 0. This M upon L is not 0, no? So therefore, the product of this into this to be 0, this must be 0. This gives us PGL cos theta plus U squared minus 2GL should be equal to 0. Then subject cos theta by this. Take this right hand side, 2GL minus U squared divided by 3GL. This is a cos theta. But we know if the particle leaves the circle, that can happen between B and C, somewhere between B and C. That occasion, this theta above the level of B means theta more than 90. Before this C means theta less than 180. But when this happens, theta less than pi greater than pi by 2. Theta greater than pi by 2 less than pi. Now take cos of this. Take in cos. What happens, people, in this inequality when you take cos pi by 2, cos theta, cos pi. In this angle inequality, when you take the cosine, what happens? The direction gets opposite this way. You know cos pi by 2 is 0, cos pi is 0, no? Cos theta, this answer. 2GL minus U squared divided by 3GL. Cos pi is minus 1. Now multiply this by 3GL. This will be 0. 2GL minus U squared minus 3GL. And subtract 2GL. This will be minus 2GL. When you subtract here 2GL, here we get minus U squared. When subtract 2GL here, it is 5GL. Then multiply this by minus sign. Then again the direction gets opposite this way. Then if this U squared is in this interval, the particle leaves the circle and begins to move in the gravity, right, as a projectile motion. Okay. Right. Next part. People after leaving the circle, it is not necessary to say it is moving under gravity. It is anyhow moving under gravity, no? As a projectile motion. Then this is the condition, right? Another one is asking like this. What is that? It is in the subsequent motion, it moves under gravity. That is okay. Show also that if u square greater than 5gl, particle moves in complete circle. A particle moves in complete circle. People, what is the condition required for this particle to move in complete circles easily? Easily. Yeah, what is that? The condition required. At the highest point C, what? Velocity or tension becomes zero. Tension becomes zero. At the highest point C, this theta will be 180. Then putting theta 180 in that tension expression, we can find tension T. That resulting answer should be positive. So that is the condition, right? Then you can write down for the particle to move in complete circles, for the particle to move in complete circles, the condition required is tension T greater than 0 at maximum position C. Not maximum position, highest position. Highest position C. The tension greater than 0 at the highest position C. You can write that is tension T at theta equals pi greater than 0. Tension T at theta equals pi greater than 0. Then tension T at theta equals pi can easily be found putting theta pi here. T at theta equals pi can be calculated m upon L 3gl cos pi plus u squared minus 2gl. Tension T when theta equals pi is equal to m upon L. If cos pi is cos 180, no, minus 1. Then here minus 3gl. This is minus 1. Minus 3gl, minus 2gl, minus 5gl. U squared minus 5gl. But this one is equal to this should be positive. M upon L times u squared minus 5gl greater than 0. This gives us, this is positive, no people? The product of this and this to be positive, this must be positive. U squared minus 5gl greater than 0. That says u squared greater than 5gl. This is how we take that answer, right? Okay. Right, people, now I will come with another one question. By that question, by discussing that question, we supposed to learn or study another one possibility of coming the question under this lesson. For this people, will take the question number 9. The question number 9. We'll take question number 9 in the tutorial. Right. Read question number 9 in the tutorial. Read question number 9 in the tutorial. And that question says people something like this. A particle of mass m, this is question number 9 now, in the tube. A particle of mass m is placed at the lowest point capital A in a fixed smooth spherical cavity of radius A. The particle is given a horizontal velocity u. In time t, the particle turns through an angle theta and acquires velocity v. If the horizontal level through A is potential energy 0 level, obtain these answers. If at t equals t, the normal reaction from the cavity is R, obtain R equals this answer. Hence, verify the following cases. Right. This is the cavity now. Spherical cavity means a hollow sphere. Hollow sphere. Hollow sphere, right? Like this. Lowest position, capital A. The particle of mass m is placed. This is A. It is given a horizontal velocity u. Right? Given horizontal velocity u. In time t, the particle turns through an angle theta. People, we are not given this theta is acute or obtuse. People, due to any reason, this given angle don't take as obtuse angle. Always in a question, when you are given an angle, right, it is considered as an acute angle unless it is given as obtuse. Right. So then this angle turn through is theta at time t. So therefore, that position I will mark like this. This is the position. And here theta. Because this is a spherical cavity. That means like a sphere, inside the sphere, like a football, people inside that. No material, that is cavity now inside, right? Cavity inside surface is smooth, right? So now by the spherical cavity, a normal reaction come in like this. R, weight mgx like this. If we produce this sign like this angle is theta. This its velocity given as v. If the horizontal level through A is potential energy 0 level, horizontal level through A. If I draw horizontal line through A, this level we consider as people potential energy zero level. Right. Now ask him to take this answer. People, what is the way? Again, we apply conservation of mechanical energy by considering this position and this position of the particle. We equate the total mechanical energies of the particle. Then first answer you can obtain. Secondly, people, at t equals t, this moment is the t equals t moment, right? This is t equals 0 moment. And this is t equals t. At t equals t, we apply F equals ma. In this case, people, the required centripetal force for this particle to move inside surface of the cavity is people coming by this normal reaction R. Right. So now applying conservation of mechanical energy. Right, here people, no potential energy because this is the level of zero potential energy. Then it has only the kinetic energy. It is half mu squared. Here, kinetic energy half mu squared plus this position is above the level P is 0. This height we need. What is that height? When I drop a perpendicular like this is A, this is theta, therefore from here to here, A cos theta, this one. From here to here, A cos theta. From here to here, it's A. Then this part going to be whole length A minus A cos theta, right? mg A minus A cos theta. You can cancel down this A. Let's ask in the episode. B is squared to subject, no? Multiply this by 2. Meantime, take this right hand side. Then we get B squared is equal to Q squared minus with this right hand side 2 E A minus A cos theta. Then you can take this A out. Then we get B squared equals U squared minus 2GA times 1 minus cos theta. This is the first answer. This is the first answer, right? Right, now we apply F equals ma. Applying F equals ma this direction. The centripetal force is provided by R and this mg. This direction R minus mg cos theta. R minus mg cos theta. Is equal to m times centripetal acceleration going to be v square divided by radius a. Then R is equal to take the right hand side mg cos theta plus m upon a v square is this. U square minus 2GA times 1 minus cos theta. We can take by multiplying this mu squared upon a mu squared upon A. When you multiply this and this A and this A you can cancel down. Multiplied by M minus 2 mg 1 minus cos theta plus mg cos theta is equal to mu squared by A. Take this mg out. Can take mg out. Here mg we take out minus 2 and this minus cos theta is 2 cos theta. And here cos theta is 3 cos theta. When you take this mg out by minus 2, when you multiply this 1, we get minus 2. This is the answer. Now, hence verify the following cases. Right. Hence verify the following cases. First thing, if u square greater than 0, less than 2Ga, particle oscillates about A. Right. Particle oscillates about A on either sides. So people, what is the condition required for this? The same conditions as we discussed in the earlier case. When the particle is suspended by a spring, that case we considered some requirement for the happenings. No, the same conditions here valid people. What is the condition required? This velocity v should be 0, having positive value for r. Then we have to equate this v expression there to 0 and find cos theta. But you know, if the oscillation takes place, right, that takes place with this theta angle as acute angle, that means theta lies between 0 and 9. Right. Now the first condition we can obtain then like this. Number 1, right, for the particle to oscillate, this should be 0. That means this. V equals 0 means v squared 0, no? V 0 means v squared 0. V squared 0 means this. V squared minus 2Ga 1 minus cos theta is equal to 0. What is this? Q squared minus 2Ga this and this plus 2Ga cos theta, right? Ga equals 0. Subject cos theta. Take this right hand side, 2Ga minus Q squared divided by 2Ga. Right? But people, when the particle oscillates, right, the oscillatory motion can happen with the angle theta acute. But the angle theta is acute angle, less than pi by 2, greater than 0. Take cos of this, taking form. What do you get? Cos 0, cos theta, cos pi by 2. Should happen this way, no? Other way around it takes. Cos 0 is 1. Cos theta is this answer. 2Ga minus u squared divided by 2Ga. Cos pi by 2 is 0. Now multiply this by 2Ga. This is 2Ga greater than 2Ga minus u squared. Then people subtract 2Ga minus 2Ga, which is 0 now, greater than minus u squared, greater than minus 2Ga. Multiply by minus sign. 0 u square less than 2. That answer comes. This is how we take that answer, right? Right. Comes the second answer. Second answer, people. If u square less than 5 GeV greater than 2 GeV, particle leaves the circular motion and moves as a projectile motion under gravity. Correct. So, again, we told people here also the condition required for this different happenings are similar to that of the earlier case we considered. In this case, when the particle people leaves from the surface, the contact between the surface of the sphere and the particle loses. When the contact loses between these two, mean this R becomes 0, people. Right? R becomes 0 mean the very first moment the contact loses. Soon after R becomes 0, particle separate from the surface. That occasion we define R as negative. Understand? At the moment the contact loses between the particle and the surface, R equals 0. Soon after the contact loses, people, we define R, the normal reaction becomes negative. Okay, therefore the initial moment the contact loses,